This video is on polynomial functions. We're going to look at real zeros, maxima, and minima. So the first thing, we're going to determine the consecutive integer values of x between which each real zero of each function is located. So consecutive integers are just two integers in a row, like -5 and -6, or 1 and 2. So they're just one integer after the other. We're going to determine between which two x values the real zeros are located. So the real zeros are the x-intercepts where our graph goes through the x-axis. So we can identify that where our graph, or if we're creating a table, goes from positive to negative or negative to positive. Also, if the x value, when we plug x in, we get a y value out of 0, well, we know that's where our line goes through the y-axis. So that would be a real zero. Okay, so we're just going to look at this, and I'm going to create a table. I'm going to choose x to plug in, and we'll get y out. So I'm just going to start with some negative values. I'm going to work my way towards 0 and then go in the positive direction. I'm not going to start too far away from 0, but if I feel like I need to go further out, I can. So I'm just going to start at -3. And when I type this into my calculator, I'm going to write over here how I type this first one. So I put the -3 in parentheses, and this is raised to the 4th power. Because if I type this in my calculator without the parentheses, the calculator is going to do 3 to the power 4 and then make my answer negative. And we know that this should be a positive value because when you raise a negative number to the power 4, well, it will result in a positive. So just be careful about that. All right, minus -3 squared minus 2. So when I type that in, I get 70 out. Just going to go through and do a few more. So work my way towards 0. So I'm going to plug in -2. Gives me 10 out. And again, I do the same thing, just plugging -2 in for x. When I plug in -1, I get -2. When I plug in 0 for x, I get -2. When I plug in +1, I get -2 again. When I plug in +2, I get 10, and I'm not going to, I did plug in +3, but I got 70 out, so I'm just continuing to go positive, and it just gets larger and larger and larger. So I just need to identify, well, I didn't get any y values of 0. So if I did, I would know that that right away was a real 0. So I need to look at where y goes from positive to negative, which is right here, and I'm going to circle both the x and y values, and or negative to positive, which is down here. So that I know a real 0, the point where my line goes through the x-axis, will occur between, where x equals -2 and where x equals -1. So I know that it will be between those values. So I'm just looking at the integer, I'm not looking at the decimal. All right, it'll also fall between here. So I know that this graph, if I just graphed these coordinates and connected the points, I could see that my graph would go through the x-axis twice. So again, I'm just looking at the x value, so it's also between x equals 1 and x equals 2. So it crosses in 2 spots. Okay, so that's pretty easy. Just create a table, identify where your graph, or your table in this case, changes from positive to negative or negative to positive. And if you happen to get where y is actually 0, that is a real 0. So that one you wouldn't put between points, you would just put the x value. All right, so here are a couple problems. Go ahead and create tables and identify between which two integers of x the real zeros occur. So go ahead and come back when you're ready for the answers. All right, so I plugged these into my calculator, plugged in x, got out y. I started where x is -2. I got 17 out. Plugged in -1, we get -4 out. When I plug in 0, it's -3. 1 is +2, and 2 is 41. So I can see here's where my y value goes from positive to negative, and here is where it goes from negative to positive. So between, again, we're looking at the x values. We have to use the y value to identify the x value. So between where x is -2 and x equals -1, and also between where x equals 0 and x equals 1. All right, so it was just a coincidence that both of our first two had one of the same points. That's not always going to happen, just in case you're curious. All right, and our last one. All right, plugged in x to get out y. I started where x was -2 and y is -23. When x is -1, y is 0. When x is 0, y is 5. When x is 1, y is 4. When x is 2, y is 9. And then it just keeps going positive, and this way it keeps going negative. So if I looked at my y values, I could say, oh, well, it goes from negative to positive here, but oh, there's actually a value where y equals 0. Meaning at this point, our line goes through the x-axis. And that's the point where x equals -1. So it's not between two values, it's an actual value of x equals -1 where we do have a real 0. All right, so let's move on to looking at maxima and minima. Right, there's a couple different types of maxima and minima. The first one we're going to call relative. Some people call it local. So relative maxima and minima. If you see local maxima and minima, it means the same thing. So these are points where the graph turns. So it might be increasing and then it turns down, or it might be going down and then it turns up. But these points are not necessarily the largest or smallest points of the graph. So if I had a point where my graph turned down and then turned back up and it kept going, this top point where it did turn at isn't necessarily my true maxima because my graph does continue going up in another spot. That's why it's called relative or local, because it is a high point or a low point, just not the complete highest or complete lowest point. All right, so we're going to estimate the x-coordinate at which the relative maxima and relative minima occur. We're also going to state the domain and range of each function. So remember, domain's the x values, range is the y values, and we're just looking at their long-run behavior. All right, so here we're just given a graph. If you're given a function, plug the function, plug x-coordinates in, create a table, and then just graph the points that you get on a coordinate grid, and you'll be able to identify the relative maxima and minima, and you'll also be able to see what it looks like, so what's happening with domain and range. All right, so this point right here is called a relative maxima because it's a top point where it starts turning down. So I'm just going to abbreviate. Relative maxima is right here, and down here where it's going down and then it starts turning up, it's a relative minima. And we know it's not the smallest value because our graph was lower down here, and like this is not the largest value because our graph does continue going up. So it's just looking at the curve. So even though I had other points on the graph, it's not where my graph is curved. So I'm going to estimate the x values. So my relative maxima It's approximately where x equals -3. Then relative minima is where x equals +1. Okay, then I also need to look at domain and range. So domain is the x values. Well, I know that as I can plug in x values and my graph will keep going because it's going up. So it is going up steeply, but it's going to keep going. And over here it is going down kind of steeply, but I can see that it's not going straight down. It's still kind of curved. So the domain, the x values are all real numbers. I can plug in any x value. The range, okay, y values. I can see that my graph's going to continue going up. This one continues going down. And there's not any points that are not included in between, so this is also all real numbers. So just looking at the long-range behavior of the graph. All right, so here's a graph for you. Go ahead and determine relative maxima, minima, domain, and range. All right, so on this one, we have two relative maximas. I'm just going to write it on there. One relative minima. Right. Relative maxima is where x equals, this one's 4, and where x equals -5. Right, relative minima is this low point where x equals -3. And let's look at domain. It looks like x, as this graph keeps going down, the x values will continue to be used. Again, this one's going to keep going down this way. It is a little steeper, but it doesn't go straight down. So I know all x values will be included. So all real numbers. Range. Okay, so this is where I can see my graph is going to keep going down on both sides. I know my largest y value is where y is 2. My graph's never going to get above that. So y is always going to be less than or equal to 2. Remember, if it was dotted, it'd just be less than, but because it includes the point, it is or equal to. All right, so that was relative or local maxima and minima. So now we're going to look at absolute maxima and minima. All right, the absolute maxima and minima are points of the graph turns, and these points are the largest or smallest points of the graph, so they truly are the largest or smallest. So identify where the graph is increasing and decreasing, and we're also going to identify if there are any relative or absolute maxima and minima. Okay, so on this graph, when you're looking at the graph and you're determining if it's increasing or decreasing, you're going to look at the graph going left to right. It's just like as you read a book. So on this graph, if I start on the left side, I can see that this is where my graph is increasing. So I'm just going to put an arrow going up, and I'm going to abbreviate increasing, keep going, and here it goes down, so decreasing. All right, and because this is the largest point, there aren't any other points that are going to be bigger than this. This is the absolute maxima. And I'm just going to put an arrow to that spot because it is at the point. The graph continues going down. So these, even though they're dots, they're not included as any of the maxima or minima because it'll keep going down. All right, so here's one for you. Go ahead and identify increasing, decreasing, relative, or absolute maxima and minima. So you need to determine if it's relative or absolute. All right, so going left to right. So here, it does look like it's kind of straight, but it is curved here. So it could potentially be really steep. So I'm going to say that this, because it does curve up, this side is increasing. I'm just abbreviating. It's increasing, then we get here, goes down, again, working left to right. It's decreasing. And then we go back to increasing. All right, we have where the graph bends, 2 spots where it turns. This one turns down, but it does continue going up here. So I know this isn't the absolute maxima, it's the relative maxima, because it's not my true largest point. Okay, and then this is also the relative minima, because it's not the actual smallest point, because there's smaller points down here, but it does turn. So relative minima. All right, so hopefully you were able to identify all of those, the maximas, minimas, and the real zeros of the polynomial functions.